Introduction to Statics. Throughout this model, I will be working from Hebler's book. Hebler's book has got different editions. It doesn't matter whichever edition that you have, they all should be fine. Statics is part of engineering mechanics. Mechanics itself is a branch of the physical sciences that deals with bodies at rest or at motions. Mechanics is divided into three different branches: rigid bodies, deformable bodies, and fluids. Rigid bodies is divided into two branches: statics and dynamics. And of course, we are interested only for this model for the statics part. First chapter in Hebler's book is introducing us to some fundamental concepts. These fundamental concepts, like basic quantities such as length, time, mass, and force, they have specific units according to the international systems of units. We have to understand them very well so that we can convert between one another. And we have to understand also the standard international prefixes. And we have to know how to move up and down according to our needs. In this first chapters, for these fundamental concepts, we will have some questions to do, like convert 2 kilometers per hour to meter per second. There are several ways to solve these types of problems. The best way is to show every step that you do so that you don't lose marks, or you can trace the questions back to see if you have done something wrong. Then you can correct it quickly. Converting 2 kilometers per hour to meter per second. So solution: 2 kilometer, we know that kilometer is equal to 1000 meter, or it's 10 to the power 3 meter. And we know 1 hour has got minutes 60 minutes, and each minute has got 60 seconds. Therefore 1 hour is equal to 3600 seconds. Now we have 2 kilometer per hour, and we want to convert it to meter per second. Now I'm going to multiply two terms in here so that each term will cancel one of these. The kilometer will go in the bottom of this fraction, and the hour will go on the top. So we need a term that is equivalent to kilometer. Of course, it's 1000 meter. 1 hour, it is 3600 seconds. Now like terms can cancel each other, and we are left with 2000 meter over 3600 seconds. When you simplify this, that should equal to 0.556 meter per second. And this is how you show every step. The next question is asking us to evaluate each of the following and express them with standard international units, having an appropriate prefix. Part A, then we say solution. For part A, we have 50 millinewton times 6 giganewton. That should equal 50 milli, it's a 10 to the power negative 3 newton times 6. Giga is 10 to the power 6, sorry, it's 10 to the power 9 newton times 10 to the power of 6 times newton square. That equal, of course, 300. 10 to the power of 6, it's mega newton square. Part B. Part B here is asking us to evaluate 400 millimeter times 0.6 mega newton all squared. This should equal 400 milli, it's 10 to the power negative 3 times meter, of course, times zero point 0.6 times zero point 0.6 because it is squared, times mega, it's 10 to the power 6 times 10 to the power 6 again because it is squared, times Newton squared. This is how you expand your brackets. This equal, rearrange 400 times zero point 0.6 times zero point 0.6 times meter times 10 to the power 6 times 10 to the power 6 times 10 to the negative 3 times Newton square. This equal, those three terms when you multiply them should equal to 144 meters times 10 to the power 6, and when you multiply these two terms together should result in 10 to the power 3 times Newton square. This equal 144 meter times 10 to the power 9 times Newton square equal 144 10 to the power 9, it's a giga Newton square. Part C. Part C is asking us to evaluate 45 mega Newton cubed divided by 900 gigagram. This equal 45 mega cube, which is mega, it's 10 to the power 6 times 10 to the power 6 times 10 to the power 6 because it's cube times Newton cube over 900 times giga, it's 10 to the power 9, but I can write it 10 to the power 6 times 10 to the power 3 gram. This further can be written as, I will cancel 10 to the power 6 with one of those 10 to the power 6, and I can write this one as 45 times 10 to the power 3 times 10 to the power 3, which is the first term here, 10 to the power 6 times 10 to the power 6 again times Newton cube divided by 900 kilogram. This all should equal 45 times 10 to the power 3 in here, 45,000 times 10 to the power 9 Newton cubed over 900 kilogram. 45,000 divided by 900 is 50 times 10 to the power 9 Newton cubed over kilogram. This further can be written as 50 times 10 to the power 9 Newton cubed times 1 over kilogram. I can simplify this further and I can say 50 times 10 to the power 9 Newton cubed times a term in here so that I can get rid of this Newton cubed and I can change this to kilo, therefore it's 10 to the power 3, and if I cube the whole term in here, so I want something equivalent to 10 to the power 3, which is a kilo Newton. This of course all times 1 over kilogram. This should equal, after we simplify, 10 to the power 9 Newton cube will cancel with 10 to the power 9 Newton cube, because all of this is cube, I will be left with 50 kilo Newton cubed, of course, times 1 over kilogram or per kilogram.